Okay, awesome. So to recap, because I know our heads were in like a completely different space just now with resume coaching presentations. We have this weather database. So please go ahead and connect to that in P-SQL if you haven't. And our weather database has reports and stations. And the stations are weather stations that are recording this weather data. And there's only two, the Chicago O'Hare Airport and the Jacksonville International Airport. And then the reports, each row is a report from one of these weather stations. And we saw that's happening every hour. And we've got the time, the temperature, humidity, wind speed, and wind direction. There's some questions around sort of the accuracy or the usefulness of this data. And there's a whole lot of reports. All right, we saw that as well. A whole lot of reports. And a little while ago, we had built up a query that looks something like this one here to search for the average wind speed. And I got into the weeds a little bit. We did a little casting here. So our average wind speed data doesn't have a crazy number of decimal places. If you all remember, we learned how to do casting in an SQL query, where if I didn't do this, this average would spit out a decimal with way too many decimal points, which is not very usable. And we don't spend a huge amount of time on it in this course, but as software engineers, you all will learn to think more and more about how to kind of analyze and categorize data like this. And we were thinking through if this average wind speed number is really useful or not. And actually, this next query here raises a really good point. How much data do we have for each day to calculate this wind speed? Because if we only have like 1 or 2 samples a day, is that really that useful? So let's go ahead. Let's run these 2 queries to wrap these up, and then I'm going to circle back to, I think there were some good exercises for us to do. So we're going to modify this average wind speed report that we just ran to count how many samples we have from each day. So I'm going to select stations.name, reports.time. We're going to cast that to a date, the average wind speed. And someone made the excellent point that we could just cast this to an integer and basically trust Postgres to be relatively reasonable in how it does all the rounding to get the integer value. And I think that makes sense. And then also we're going to count how many reports we have for each day. So from reports, join stations. So we're going to join our stations and reports so we can see which reports are for which station. On reports.stationid equal stations.id. And we're seeing, we saw for the first time a different way of doing group by and order by. And let me actually just put here in comments what these are the same as. I can double check this. And in fact, we should ask, I think, ChatGPT in a moment, but I'm like 99% sure on this, that this is a shorthand that looks at the columns we're returning in our select statement. And instead of having to type out the name, and since the name of this one will be AVG for average, and this one for count, unless we give them an alias, another way that Postgres lets us identify what columns in our result set of rows we want to group or order by is by number. And think like first function argument, second function argument, first column, second column. And let's see if ChatGPT will confirm this here. And I figure it's kind of interesting to see how I use this, though now it wants me to regenerate and log back in. And I really lost my ChatGPT. And look at that. I didn't even need to give it that much. And indeed, this is basically confirming what we just said, that groups by columns 1 and 2. Here, they're using the column names. I think ChatGPT is honestly taking us down a wrong path here. At this point, I think we're better off looking for like a source, because I'm pretty sure if we dig through this, it'll find an example of using those numbers. But I don't want to go too far down this rabbit hole right now. If someone maybe wants to find an authoritative source so we can just confirm that our understanding is correct and share it in the chat, that would be awesome. So I always like I'll run code to figure out what it's doing, but then I always like to find some sort of documentation that confirms my understanding is correct. So in any case, we're grouping by these first two columns, and then we're going to order by them as well.
Yeah, I think you left out the by.
Yep. Thank you, sir. There we go. And we've got our same data here, but here we see this is what we cared about. I went on a little bit of a tangent there. Just to reiterate, we've added to our average wind speed for the day the number of samples. And so, thinking about this sort of from a real world perspective, if there's a huge range in the number of samples per day, well, the more samples, the better. Though if one outlier throws it off, that could actually be a problem. So is more samples better? Maybe not necessarily. If there's like a huge gust of really fast wind that happens for like 30 minutes, and that's when the sample happens and that skews the data for the whole day, that could cause concern. So this is helpful. But then kind of something that's good to think about too is, once we understand the intent, we don't always have to do kind of exactly the original problem statement. And basically what we're saying here is, hey, maybe we should look at the minimum and maximum wind speed for each day. Maybe that's a little more useful or a little more accurate. And they both have value. Really, we could look at all three, right, and see what it was. And I think what I'm going to do is I'm just going to hit the up arrow, and I'm just going to modify this query that I already wrote. And in fact, I'm just going to add the minimum wind speed and the maximum wind speed. And we'll leave the average in the count because I think it'll be kind of interesting to see. And now this is a whole lot of data. But this is kind of neat to see. We've got a min, a max, an average. And so, the average is roughly in the middle most of the time, and that seems about right. So that's actually kind of good. But it's interesting, and this does kind of help us, I think, get more useful data. Here 0, 10, and an average of 5, like those are some extremes. So it's interesting to see. And there is a pretty huge range in what the value for any one report could be. And just, I think the more we kind of get in the habit of thinking about and like digging into problems and data this way, the more it helps us overall. To kind of circle back to these exercises to kick off this lesson, I think these would all be good to do. Maybe let's just like take 10 minutes, a couple minutes to do this individually. Or actually, does anyone want to volunteer if they have one of these done? Or maybe to like screen share and live code it and build it out?
I did it using the max and the min functions. If you want to see that.
Yeah, that would be awesome. Here, I'll stop sharing. Perfect. I was gonna say if it's easier to paste it in, you can do it that way too, but this is perfect.
All right, the mute button ran away from me there for a second. So yeah, I did it using the max and min functions. I looked at what it wanted first, find which weather station. So I did name from stations and then looked at what it wanted the end result to be, highest temperature record. So I added the max temp F, joined reports where they meet up.
Nice.
It by name, unlimited by 1. And when we run this, it comes out with Chicago at 103. Basically just did the same thing just switched from max to min on that one. And still O'Hare at -16. And then getting them both, I just combined the two in the select statement and got them both.
Nice. That's awesome. I have one question for, let's say, that first query for the weather station that has the highest temperature record.
Mm-hmm.
Do we need to group by name if we are also limiting our result set to 1 and using the max function?
Probably not.
I'm not
When I did,
100%. Oh, sorry, go ahead.
no, when I did it originally, I just did the group by name kind of automatically. So, yeah, I guess it wants it in there.
And it looks like I was
Must
wrong
appear in the
there,
group by.
or be used in an aggregate function.
Well, if you're already querying the max, do you really need the limit of 1 in there?
Yeah,
That's a
because
good
otherwise it
question
returns.
too. What if we?
Otherwise, it returns all of them.
Oh,
The
Right,
the
that's a
max
good
is an
point, 'cause we have
aggregate.
as well.
Yeah, and the max
I see.
being an aggregate function means that I'm going to have name in the group by because it's going to try to report by name, right? And automatically. So that's why it's giving me this group by, must be in the
Yeah,
group by clause.
yeah. And I think you hit the nail on the head there, Aaron. And I think I was sort of confusing aggregate functions with the where clause. Because you're right that like max, what max does is it's an aggregate function that once we have our rows of results, looks over all the, result columns from all our rows and aggregates it together and finds the highest. And I think I was thinking of like using a where clause or something. I think the way I was thinking about it, we would do select name and temp F, order by temp descending limit 1. I think that might be another way to do it that wouldn't use a group by or a max. But I think in some ways, I actually think the group by and the max is more elegant. This is awesome. And actually, I'm curious to see if what I'm thinking would actually work. And Aaron, thank you very much for demoing and sharing that. That was great. So let's
Thank
see if this actually works. To get, let's see, what do we want here? Which station has the highest temperature report? So stations.name and reports.temp F, if I have that column name right, from stations join reports on stations.id equals reports.station ID, order by reports dot temp F descending limit 1. Maybe is it,
It's just DESC, I think.
let's see here. Missing from clause entry. Oh, and I have a typo up here. I actually think the group by approach is more elegant and the way to go, but I think it's cool to see multiple ways of doing the same thing. And also just to share sort of where I got confused in my thought process. So there's 2 ways to do it, right? We filter with the where clause, which filters up front, like so less our results only return 1 row here with this query. When we use the group by, the results return a whole, it's sort of, and you could think of it as we actually had a bunch of stuff maybe returned, but then at the end of the query, the group by condenses, all those rows, and then the aggregate calculates the value. So it's just interesting to think about 2 different ways of doing the same thing. Awesome. Let's take a look. So if you scroll down a bit or over here, I will put this. Let's see, exercise 2 years, high, low temperature, humidity, and wind speed for each day at each station. I think I will leave this as an exercise for you all because I think we've been tackling this. And so if this sounds like something that is worth doing, maybe just make a note to yourself to tackle this right when we wrap. What I do want to show is, I think this next bit starts to get to some interesting stuff. We want a monthly average, and we're going to use a subquery. And we didn't talk about subqueries a ton in class, but we've seen them in a lot of demos. Like several people have used, I've been calling them nested queries, subqueries to demo how we can build these more complex queries together. And so this, I think, is kind of cool to see because we want the monthly average high and low temperatures for each day, for each month. And interestingly, I would have to check what this left function does in Postgres. Let's see here. So this is actually pretty nifty. It gets the first n characters in a string. So that's kind of cool. So what they're using this for here is gets, let's see, 7, 20, 11. That's 4, 5, 6, 7. I apologize. My VS Code suddenly seems to be slowing down on me a bit. I'm not sure what the issue there is. Let's see if I have anything I can close out real quick. Maybe free up a little memory. It is almost always Chrome that eats up memory. Anyways, so we get these first 7 characters from this larger date time string that looks something like this. You know, 01-01 T, whatever it is. So that's a very useful and nifty Postgres function right there, actually, that left function, because it lets us take structured string text data, like say a formatted, here we cast a date to text, and we can grab just the first bit that we need. So that's pretty cool. There's a lot of different ways to do that, but it's neat to see those in action. Here, I think we see a bit more clearly what's happening. We've seen average, we've seen the alias where we're getting the average minimum and maximum temps. And note that this is all operating on this other subquery that's nested. So this gets the data really, and this filters it. So there's multiple rounds here. And what we're doing here is we're getting the date and we're casting that timestamp to a date. And we're looking at the same column twice, which is kind of cool to see because we have a group by here and we're grouping by, I believe it's going to be the station name and the station date. And then we aggregate, and we aggregate first on the tempf column to get the minimum. And we aggregate again on the same one to get the maximum. And we do the same thing here with humidity and the same thing here with wind speed. And we're doing this from reports, and then we do our join. And here, this, I believe, is an alias, just this little T. So I think once we do this nested query, I think it needs to be given an alias. And then we again do the grouping and the ordering by what we care about. And let me go ahead and just type this out. And I would recommend that you all type along with this as well. I know I have been doing some copying and pasting, but I kind of believe, and as far as I know, science kind of backs me up that certainly writing by hand, I think typing too helps bring stuff into memory. So let's select name and then left date text, just get the first 7. And let's get the average minimum temp as average minimum temp in Fahrenheit. And the average maximum temp as average maximum temp in Fahrenheit. From, and here's where it gets interesting because we're building our subquery, our nested other query inside here. So we're doing another select, stations.name, time, cast the date as date. And this is honestly where I have to say I would probably write this in SQL at this point. Like putting it all into P-SQL is a bit much. And in fact, I've already made a typo here. So I am gonna just eat my words. Actually, folks, we're gonna do it the other way. Otherwise, we'll be here forever. But the key to this, and what I would recommend doing if you're looking at this and feel like it's not clicking, And I think it is important for this to click at this point because we're seeing a lot of pieces that we've seen before. Take a little time after we wrap, break this into pieces and run each piece. Take this subquery and run that first. And in fact, I would even take this and get rid of like everything except the date and one of these min fields. Run this, make sure you feel good about what's going on in the grouping by, and then add the rest in. And once you feel good about what's happening here, that's like half the battle. Again, the thing to remember here is this little t is, I believe, just an alias that we need when we use a subquery like this, and then build out this larger query that works from this subquery. And what we can see happening here is we've got the name, we've got for each. Now, is this actually giving us our monthly average? It is indeed. Because if I look here, I see that is January, that is February, that is March. I know it's a little confusing, like looking at this data. So we're looking at months of the year here. I would even cast this. I'm sure there's a way to format this into like the actual name of the month, but I'm not going to worry too much about that right now. But if anyone wants to tackle that, that would be cool. And then we see our average minimum temp and our average maximum temp. And again, man, all this precision, not really useful. We'd want to round that down dramatically. And then here's the Jacksonville data as well. Now we can kind of get to something interesting. Let's do something called a view. And I've sort of mentioned this and hinted at this. So we've kind of gotten a little bit of a preview. And I'm going to build this up. I'm going to take my own advice and make this much smaller to begin with. So please do code along here. So let's build the view and then we'll talk about what it does. Create view daily summaries as. We're creating the view, and now we're going to tell Postgres, create this temporary table called a view. And here's where you're going to get the rows to populate it from. Here's where you get the data from it. Now we give it this query. Select stations.id as station ID. Stations.name as station name. Time, date as date. And let's just do the minimum temp just to get the ball rolling. We'll worry about all the other things later, or I might skip over it altogether because this is the most important part. Minimum temp. And here we don't have to say as because it's an aggregate function. And I'm not going to use the comma because I'm stopping here. Oh, there we go. Hopefully VS, I've not lost it here. I think we're good. From reports, join stations on reports station ID equals stations.id. And now we need to do our group by. I note here we group by the first and the third column. So we're grouping by the station ID and the date. Let's add the semicolon and see if this runs. It did run successfully. Very interestingly here, we don't see results. Postgres created this view, which is like a temporary table. And check this out. If I do /t to list all the relationships here, we had these tables and this ID sequence, but now we have daily summaries as a view. Now, I'm not sure if this lives, like when I exit Postgres and return, it might. I'd have to dig up on that to check. But certainly as long as you're running a pSQL session, this view will stick around. And the cool thing is whenever I do stuff with this view, Postgres runs that query again. So this gets updated with the new version of the data. So tomorrow when we want to get this and we use this view, Postgres will run this query again to get the fresh data, which is awesome. And that's the power of a view. There's something called a materialized view where instead of running the query every single time, whenever you like insert any data, Postgres will kind of keep the view up to date. So it kind of does less work up front. But we use them really the same way. And so you all got great practice building these super fancy, subqueries and nested stuff. And actually, one of my notes to myself is we should probably introduce views sometime this week a bit earlier, because I think a lot of you could have made good use of them. But the nice thing about seeing them today is we've kind of built up to it. And now let's go ahead and use this view. I'm just going to do select star from daily summaries. I just want to see what this is like. And it's exactly like a table. Isn't that awesome? And we have the things that we put down. I'm not going to worry about the rest of this stuff too much because we're really getting the good stuff here with the view. And we really only need one of these aggregation fields so that we can do some stuff with our data. So let me pause and check in and see what questions people have here, because this is kind of cool and kind of new. And I want to see what's on people's minds, or if there's things you want to go over, or hopefully you're kind of like, all right, this is cool. This makes my life easier. So what's on people's minds?
This is actually back to that previous query. I was curious about that T, and I tried changing it into like other things like table and stuff like that, and it didn't like any of them. It just wants T. What's this? Do you know what's the significance of that?
I suspect that is the funkiness of Postgres syntax for subqueries.
I changed it and it liked my changes just fine. Like I did like temp table and it didn't have a problem with it.
Yeah. Brian, there may have been another syntax error floating around somewhere. Let's find. So we can either ask ChatGPT or, so in terms of online resources, by the way, I should have said this. The Postgres documentation is extremely good. And a lot of it is useful and quite readable. It is, however, dense. And so I can understand that this often is not a good first source. This site, postgrestutorial.com, is extremely good and much friendlier. And so I recommend this as your go-to, like avoid W3 schools. First, look at this. If you really need to understand exactly how something works, look at the Postgres docs. And after this, probably the Geeks for Geeks site is good. So let's see if they dig into it and give us an explanation here. But yeah, I think we can make that alias whatever we want. We're not really saying it here, so I'm gonna just do a quick Google one more time. But basically, yeah, we see here as T. I'm pretty sure you can change it. I would like create a tiny example and try it again. To recap, what we're talking about here is if we look at this subquery, select name, from, and then so here's all the subquery stuff, and it closes out, and then we just have T. I'm pretty sure this is just a convention. I'm pretty sure Postgres needs this subquery to have an alias, so we can refer to it if we need to. But because we don't really need to use this for anything, and there's no reason to give this a meaningful name, I think the convention is just use the term T. And we can, let's change this to U, and we can run it, and I suspect this will work. Although I may eat my words, let's see. Yeah, so I would double check for a syntax error, else we're right. What else is on people's minds? Are you all maybe like kind of excited about using views? Are we feeling good about using views?
I'm still trying to wrap my mind around it.
About which part? Yeah, let's which piece of the
Well,
puzzle?
I'm just trying to
want
parse
look at?
that the last query you made to create view daily summaries as select stations
Yeah.
ID as station ID.
Yeah,
There's just a lot going on there.
yeah. Let's break this down. And let me go ahead and do a little copy paste here so I can modify this and we can look at it because it's a little tough to see it in pSQL. So let's simplify this. And let's simplify this to with I think for the group by we can even just do station name and date since we have these aliases. We'll see if Postgres complains about that or not. Though it looks like I actually don't want station. Let me make sure I get this right. Oh no, station ID, station name, and date. Let me put all of this stuff kind of together. Because I find the visualizing it like this helps me. You know, date is a bit of a special keyword in Postgres. I wonder if that's part of what's going on here. Let's see if this works. Syntax error at or near from. Oh, because I have a comma here when I don't want one, I suspect. Let's try that again. Column station ID must appear in the group by clause. Right, this should probably be station ID, shouldn't it? Excuse me. Because we need to group by on that. Because basically when you use a group by, each column in your select either needs to be in the group by or be aggregated on. And Aaron, I think you kind of pointed that out earlier when I was getting a little confused there. And I sure thought I did, but maybe this is where the aliases don't work. And I think this is what's going on here. Let's find out. Yeah. So this is something that's good to be aware of with group by, actually. Same query. Pretty darn sure I don't have any typos. But when I run it, I get this error column stations ID must appear in the group by clause or be used in an aggregate function. And I'm sort of like, well, hey, what the heck is going on here? I have this as statement right here. What's the problem? And I'm not 100%, but I'm about 60 to 70% sure that the problem is I'm not sure if Postgres lets us use these as aliases in our group by. Like if we just did this, let's see what happens. Yeah, so that works just fine. And so that, by the way, is why we see those numbers showing up. And that actually makes a lot of sense because it's nice to be able to have aliases, especially when we're using group by. But then we can't use our aliases in the group by clause. We can't use the alias names, just a weird limitation of Postgres. So we've got this query here that we've simplified it down. We're grouping by station ID and we're grouping by date. We're grouping by column 1 of our results and column 3 of our results. And we get the station ID and the station name and the date. And we're getting it from reports, and we do our join as we've seen before on here. So this is the query that's getting us the data that we care about. And then turning it into a view is relatively straightforward. And let me go ahead and drop view daily summaries. Let's see if that does it. There we go. So that we can create it again right here. Create view daily summaries. And really, basically, to start getting your head around this, you should think of this as create table, because it lets us use it almost exactly the same way as a table, right? It's working differently. The view actually updates, which is why it's called a view. Like when we get new data into Postgres, it runs this whole query again, which is pretty cool. And then we just need to add at the end of here, as, if I have that syntax correct, because that's the syntax for creating a view. And now what this should let us do is create this virtual table from that query. And we can treat this exactly like a table. And do all sorts of nifty stuff with it. And I can query it just like a table, and that's what we see happening here, where I can do select station name, and let's just do left date, this whole little dance to get the year and the month from our date string, and the average minimum temp as average minimum temp from daily summaries from our view. And we can do the same group by and order by stuff that we've been doing with tables, because for all intents and purposes, the view is a table. And views are great. Views can also be used for security reasons too. Like we might not want to give certain programs, or maybe all programs, direct access to the tables, say to delete stuff. So with a view, if we need to give people like view only access or programs view only access, that is one good use case for a view. A materialized view, I don't think I'm going to dig into too much. Just to reiterate, what happens is every time I run a query that uses a view, Postgres runs this query that generates the rows, the result set for our view again. And sometimes that can be a lot of work if it's a complicated query. So sometimes what makes more sense is whenever there's a new report, let's update the view when the new report gets inserted into reports. And that's called a materialized view. And that's getting a little more into the weeds, but that's the two pieces here. And that really kind of covers most of the stuff we wanted to look at here. So we can break and we can maybe do a little schema design. I'm not sure if it makes sense to dig into the next exercise. But what's on people's minds and what questions do people have? Let me actually, yeah, what's on people's minds?
Will making views be something that we need to really think about for the assessment?
No, it will not. It, the nice thing about a view is if you start feeling like you need subqueries that get complicated, views are actually easier. Again, the comparison being writing these queries versus writing the one query and then turning it into a view. But you don't have to use it. And it's not really required. It's not, we're not even explicitly pushing you to use it. I realize it's kind of a new thing, but I think it actually becomes quite useful, but it's not, you won't need to, you can do perfectly fine without it. And we would have put it in a lesson if we really were pushing it in the assessment.
I guess follow-up question, will those kind of multi-dimensional queries where it would be convenient be something that appears on the assessment?
You might need some subqueries, but again, if like views were critical, we would have covered it in class on previous day. Really the most important things will be like these aggregate functions and group by and joins, and being comfortable looking at CSV files and turning them in, creating tables and rows, and then getting that CSV data in. The CSV data will not be as challenging as the 64 slices assignment, where there was real open-ended and there were some gaps. I can't promise it'll be like 100% clean, but it'll be pretty well structured and well ordered, and not there won't be like a pizza toppings that like has some real design challenges in it.
So we won't need to like make a Python function that cuts every comma after the seventh one.
Not unless you want to. No. The intent is you can use copy and SQL and P-SQL and you'll be perfectly fine. And the more open-ended 32 flavors and 64 slices assignments go a bit beyond most of the assessment. There will be a good amount of querying and grouping and aggregating. And then you will have to construct tables and rows and stuff. But no. Yeah, what else is on people's minds, whether it's about the assessment or this stuff or anything else kind of related to SQL that we've been looking at?
I just had a question on the casting. So when do you need to cast something? When would you need to cast a date as a time, or a time as a date, or why would you want to do that?
Yeah, great question. First of all, you probably will not need to use casting on the assessment. I'm like 90% sure. It is cool to see. That said, it's really for if it's helpful for us, but also because this data doesn't exist in a vacuum. We might be using this for a report that we're showing to the product management team. We might be sending data back to Python. So there's just all different situations when you might want to format your data in a certain way. And this is a good example really right here, where it makes sense for each report. And let's actually jump up a bit to a previous query if it is yeah, let's jump up to this one of these initial queries. The average wind speed for each day. Remember that for the reports table, the time is a timestamp. That looks like this, right? Date, month, year, month, date, minutes, hours, seconds. in this case, we want to group by day. So it makes sense that we want this really rich information about time to be saved in our data, right? We wouldn't want to change this data model to have the time be a date. We want to know down to the hour and the minute for weather reports. But in order to get information about the average wind speed for each day, in order to do it with SQL and entirely inside Postgres, we need to be able to like group by day. So we want to turn this timestamp into something that just represents the date. So that's a really good practical example of how that helps us query our data. And then again, a lot of the times, you know, even if we weren't doing this, if we were generating a report for our boss, they don't want to know the second that this stuff happened. They might want this to be in a different format. So there's all sorts of reporting reasons why we sometimes want to show data in different formats. So the short answer would be, you don't have to do a lot of casting in Python or JavaScript because those are dynamic languages. Variables aren't strongly typed. But, you know, there's all sorts of times when you've got a variable in Python that is, you know, maybe it's an integer that's stored as a string and we then want to use it as an integer or a date that we want to show in different formats, and all that stuff is true with Postgres as well. So I hope that helps a little bit.
Yeah, it does. Thank you.
Totally. And Francisco, yeah, thank you for jumping in as well. And Clarice, I know you had something on your mind as well.
Well, I was just wondering for the test, how are we tested? Is there another test software suite? And yeah.
Yeah, great question. You will have, just like the last two assessments, a GitHub repo through that will kind of get you through GitHub Classroom that you'll clone. And just like with the last assessments, once you have written your SQL code, you will push that code up to GitHub. And what's happening under the hood there is the way GitHub runs all these tests is it spins up a little virtual machine container and actually, you know, runs the code. And so same thing, GitHub will spin up a little virtual machine container that has Postgres inside it and run your SQL. And then we do have tests as well that they should pass, and you should be able to run those tests locally as well. So you can kind of see which tests do and don't pass. And there's not, you know, that's a good point. We might do a little bit of demo of that in the review session tomorrow, but the tests with SQL are actually relatively straightforward relative to, say, Cypress, where there's not a lot of extra steps or complexity. But remind me, and maybe we can at least like demo looking at what a test file looks like, or maybe we'll do that when we release the assessment. That might actually make the most sense. That's a great point. Thank you for asking, Clarice. What other questions do people have, and what's on people's minds, whether to review something or about the assessment or anything else related to SQL? How are you all? Let me go ahead and stop recording.